In this video, we will see how we have to write 3-address code, then how we have to optimize the 3-address code using DAG concept. For that, I taken an example I equal to 0, s equal to 0, while I less than or equal to 10 means we have to evaluate s equal to s plus I, then we have to increment I equal to I plus 1. So this is simple code. Okay, so for that we have to write 3-address code as well as we have to optimize it using the DAG concept. So how we have to write a 3-address code means first we have to check the statement. Okay, here the first statement is what? I equal to 0, next s equal to 0. It's a normal simple statement. Okay, then here we are having a looping statement. While I less than or equal to 10 means we have to evaluate this block. We have to evaluate this block. Otherwise, we have to skip out of that block. Skip out of that block. So this is a concept. Okay. So first we have to write the syntax directed code for this. Syntax directed code for this. So initially we have to write the simple statement I equal to 0 and s equal to 0. Next we have to check the looping statement. While I less than or equal to 10 means we have to evaluate the true part of this. True part of this, that is called as e dot true expression. This is called as expression. This is called as expression. Okay. If the expression is true means we have to evaluate the true block. Okay. Otherwise we have to move on to the false block. Okay. So whether it is true or not. If it is true means we have to evaluate true block, otherwise we have to move on to false block. Okay. So this is the condition for this. Okay. So here what is a true block? If the condition satisfied means we have to execute this block s equal to s plus I equal to I plus 1. So these two statements are called as true block. These two statements are called as true block. Okay. Then if the condition failed means where it goes, it come out of that loop. It come out of that loop. Here nothing is there. Okay. So if the condition is true means we have to execute true block. Okay. That is s equal to s plus I. Okay. I equal to I plus 1. After evaluating it, where it goes, again it goes to where means the starting address of the loop, starting address of that loop. So again it goes to here, while. Okay, then again we have to check whether I is less than or equal to 10 or not. If it is less than or equal to 10 means again we have to evaluate true block. Okay, then again go back to starting of while. Okay, so the loop will continue until it meets I is not less than 10. Once if I is not less than 10 means automatically the condition failed. The condition failed. Okay, then it will go to where means e dot false. Okay, expression false block. Where it goes means it goes to the end of loop. End of loop. Okay, so this is a normal procedure for writing the 3-address code. 3-address code for looping statement. Okay, so this is syntax director definition. This is called as syntax director definition. Okay, now we will see how we have to write a 3-address code for this. Okay, so first for writing 3-address code, assign memory address for each and every statement. Here this is a 3-address code. Okay, the first statement is what? I equal to 0. Okay, then address line 101, write the second statement s equal to 0. Okay, what's the third statement? While I less than or equal to 10. Okay, whatever the condition statement, looping statement. Okay, we have to use only if statement instead of while. Okay, we have to use a if. Okay, if I is less than or equal to 10 means, okay, it go to where? It go to e dot true. true. Okay, we don't know the address of E dot true, so you just write the label. Okay, after completing the entire code, find out the E dot true address and replace it. Okay, that is called as back patching. Okay, so initially we don't know the address of E dot true block. Okay, so just write the label name. Next, suppose the condition not met means we have to skip the entire loop. So write go to E dot false. Okay, if the condition satisfied means we have to execute E dot true, otherwise we have to execute E dot false. Okay, that is the statement. If I less than or equal 10, execute E dot true, otherwise execute E dot false. Okay, so the entire code for the while statement over. Okay, next come to the next statement. What's the next statement? S equal to 104. Just write S equal to S plus I. Okay, instead of evaluating this, use temporary variable T1. T1 equal to first S plus I. Okay, and then we have to assign the T1 result. T1 result into variable S. Okay, so next line 105, just write S equal to what? T1. S equal to T1. Okay, next check the next line of the program. I equal to what? I plus 1. First evaluate I plus 1. Okay, then assign the result into variable I using temporary variable. So for that I am using T2 variable here. T2 equal to I plus 1. T2 equal to what? I plus 1. Okay, next 107 line, just assign I equal to what? T2. I equal to T2. Okay, now we evaluated this. Okay, then what's the next statement? Next statement is what? Closing. Okay, closing in the sense it indicate again the statement goes to where means the starting of while. Okay, so 108 line, just put go to of the starting address of what? While. Okay, what is starting address of while? If. Okay, so the starting address is what? 102. Starting address is 102. Okay, then what's the next statement of the program? Nothing. Okay, so just write in 109 is dash dash. We don't know. Here we don't know what is there. Okay, so just put dash dash. Okay, now check whether all the statement has its address or not. Okay, here I equal to 100th line we are having I equal to 0, no problem. Next 101 is equal to 0, no problem. 102, if I less than or equal 10 means go to where? E dot true. Okay, so what is E dot? Here the E dot true is what? Label. We have to refill it. So what's the E dot true? E dot true is what? S equal to S plus I. S equal to S plus I. So we have to find out the address of the starting address of S. Okay, so what is the starting address of S? T1 equal to S plus I. S equal to T1. Starting address is what? 104. Starting address of the E dot true is 104. So you just write instead of E dot true, just write 104. Okay, next statement 103 we are having go to E dot false. What's the E dot false? E dot false is again label. We have to refill the corresponding address. Okay, so what is E dot false? Here the E dot false is the next statement of the end of looping statement. End of looping statement. Okay, so the next statement or address of the looping statement end. Okay, so here the looping statement end is what? 108. The next address of the looping statement is what? 109. Okay, so here the 109 is called as E dot false. Okay, 104 is called as E dot true. Okay, 109 is called as E dot false. So here we have to refill 109. We have to refill 109. Okay. So this is called as the 3 address code. 3 address code for a given program. Okay. Then we have to construct DAG. We have to construct DAG as well as, so first we have to construct syntax tree, then we have to construct DAG. Okay. So how we have to construct it? So what's the first statement? I equal to 0. Okay. So start with I. This is called as syntax tree. Okay. Then we will optimize it. Okay. So I equal to 0. Okay. What's the next statement? S equal to 0. S equal to 0. Okay. What's the next statement? If I less than or equal to 10 means go to E dot true or not 4. Okay. So if I less than or equal to 10. I less than or equal to 10. Next. I less than or equal to 10. Okay. Where it go to the address line 104. Go to address line 104 for this statement. Okay. What's next statement? Go to E dot false. Construct tree. You just write. Go to line number 109. So this is the first statement. 100th line. This is 101. This is 102. This is for 104. Okay. Next 100. Sorry, this is 103. Next 104. Okay. How we have to construct it? 104. 104 is what? T1 equal to S plus I. So S plus I. This is called as what? T1. So S plus I equal to T1. This is for what? 104. Line number 104. Okay. Then we have to construct the diagram for 105. Okay. What's 105? S equal to T1. What is T1? T1 equal to S plus I. Okay. So 105, line number 105, S equal to, S equal to T1. Okay. What is T1? T1 equal to T1 equal to S plus I. S plus I. Okay. This is for line number 105. Okay. Next we have to draw syntax tree for the next line. Okay. What's the next line? 106. 106. T2 equal to I plus 1. Okay. So T2 equal to I plus 1. I plus 1. Okay. Next line 107. Okay. So 106 and 107. Okay. What's 107? I equal to what? T2. What's the T2? This one. Okay. So this is syntax tree for 106 and 107. Okay. And then 108. What is 108? 108 just we have to mention the go to address of the looping statement. So go to this address is what? 102. Go to 102. Okay. That's all. So these are all the things are called as syntax tree for the 3 address code of looping statement. So initially, what's the first statement? I equal to 0. Second statement, S equal to 0. Next statement, if I less than or equal to 10, go to line number 104. Okay. Next, T1 equal to 104, sorry, 103, go to line number or address number 109. Okay. Next statement, T1 equal to S plus I. Next, S equal to T1, T1 equal to what? S plus I. Okay. Next line, address number 106 and 107. 106 is what? T2 equal to I plus 1. 107 is what? I equal to T2. Okay. Here I combine the two. Then last line, go to 102. So, this is a normal way of constructing syntax tree. Next, we have to optimize it. Okay. How we have to optimize it? So, what is the first statement? The first statement is I equal to 0. Okay. For line number 100, carefully listen. For I equal to what? 0. I equal to 0. Okay. Next statement, S equal to 0. S equal to 0 over. Okay. Next statement, if I, here we have to call I. Here what's I variable? I less than or equal to 10. Okay. Here what is I? I is already represented in the first line. So we have to call the variable I. Call the variable I. Okay. I less than or equal to 10 means, okay, I less than, I less than or equal to what? 10 means go to line number 104. Okay. So this is a DAG. Okay. Here I less than or equal to. Instead of using I, we have to call the line number 100. Okay. So here this is a line number 100. This is a line number 101. Okay. This is called as 102. Okay. In 102, I called the variable I in line number 100. So I less than or equal to 10, go to 104. Okay. Next, what's the next line? Next line is go to 109. So 103 is what? Go to 109. Okay. Here we can't optimize anything. Okay. Just write. Okay. Next line, what's the next statement? 104 is what? T1 equal to S plus I. Okay. So here 104, just see the difference. 104 T1 equal to what? S plus I. Okay. Here what is S? S is already stored in the line number 101. I is already stored in line number 100. Okay. So we have to refer that. We have to refer 101 and 100. Okay. We can't use again IS and I. Okay. So T1 equal to what? S plus I. Instead of writing S and I, you directly point out the variable used in line number 101 and 100. So here what we need? Yes. Here what we need? Yes. Okay. Instead of using S, you directly point out the address line of yes. Address line of yes. Okay. And next what we need here? We need S plus I, no. So here where we are having I is stored in line number 100. Okay. So you just point out this. Okay. So T1 equal to what is this? Here it point out the line number 101. Yes. Yes plus what? I. S plus I. Okay. So this is for 104. Okay. Next we have to construct DAG for the line number 105. What's the 105? S equal to T1. S equal to what? T1. Already S is stored in where? S is stored in where? S is stored in the line number 101. So in that we have to replace S value. Okay. So here the next statement is for 105. Okay. Next statement is for 105. Okay. What is 105? Yes. 105 is S equal to this part. Okay. Already we constructed DAG for this here. Okay. Now we have to assign the entire thing into where? Yes. Entire thing into yes. Okay. But that S is already stored in where? The line number 101. Okay. So we have to assign the entire thing into again where means S. Okay. So we have to assign. Here we have to use here equal points to which variable means it points to variable yes, points to variable s equal to t1, s equal to what? T1. Okay. So this is a line, this is a DAG for line number 104 and 105. Okay. Now next we have to construct DAG for 106 and 107. What is 106 and 107? 106 is T2 equal to I plus 1. 107 is I equal to T2. Okay. So how we have to construct DAG? Okay. Here because the variable I is already used. Okay. Already used in where? Line number 100. Okay. So in line number 100, what's the I value? I equal to 100. So I equal to 0. Now we have to replace that 0 value by I equal to I plus 1. I equal to I plus 1. Okay. So how we have to construct it means here the statement is this is the DAG for 106 and 107. 106 and 107. Okay. So what is 106 and 107 means? So initially we have to calculate T2. T2 equal to what means? I plus 1. I plus 1. So I is stored in where? I is stored in where means the variable, sorry, address line 100. So just make connection between the plus and I. Plus and I. Okay. Plus and I. Here, so T2 equal to what? T2 equal to I plus 1. Okay. Then we have to assign that result to where again? Variable I. Okay. So in 107 here I equal to this thing. So again call the same variable. Again call same variable here. Okay. I equal to this thing. I equal to this thing. Okay. So this entire diagram represent the optimized code of which one? Optimized code of these things. Okay. Thank you.